Hello, everybody. Welcome to Lightning Talks. As all of the events here, this one is also virtual, so we have about half an hour's worth of pre-recorded talks and one exciting live contribution at the end. So take it away.
Hello, DebConf. I'm Francisco, and I'll be talking about this little Python script that I wrote to track the Debian release. So, when I'm talking to people and they know that I'm involved in Debian, they ask, when is Debian's next release? When is Debian going to release a new version? And we have to explain to people that Debian does not have a set release date like Ubuntu, for example. Which means we can't really tell people when it's going to be out, because the decision to make a new version is made by the release team based on certain criteria, and one of these criteria is what we're going to talk about. So being blunt, it's done when it's done. And how does this work? We have new packages and new versions of existing packages going into Unstable. Unstable is the main entry point to Debian. There are other ways to enter to make, but Unstable is the main way. And once they make it into Unstable, they remain there for a little time, they go through a little testing, and then they migrate to testing. Which means testing is always the up-to-date version of Debian, which packages have been through a minimal round of testing. And this is a continuous process, so testing is always up to date to the newest versions of software. The only exception to this is when the freeze happens. And the freeze is when the release team decides that it's time for a new release, which they try to make every 2 years, but it doesn't really mean 2 years to the date, of course. And when the freeze happens, the flow of packages into testing becomes more and more restrictive, so we can have time to fix the bugs and make a stable release. So this works like this. The release team sets a freeze policy, which means it's a document that describes how the freeze is going to work, how many phases it's going to have, and how the restrictions are going to be harder and harder. And when we reach the full freeze, no new packages are allowed at all, except those that contain bug fixes. And the full freeze takes as long as needed to get these bugs fixed. Of course, the number of bugs is never going to get to 0, but when the release team decides that it is low enough, they sort out the remaining bugs by either removing the package from stable or just sending it into stable anyway, because they decide that that bug can be fixed after the release is done. So how do we count the bugs? The first option is the authoritative source, which is the release critical page in the bug tracker, because it's an official version. It is an HTML which is easy to read but needs parsing, and is updated every few hours. The other option is the Ultimate Debian database, which has plenty of options and customization, offers a JSON file which is easy to use, accessible through an API, and is always up to date. So we use Python script. We use the JSON and request libraries to make a request of UDD, and we count the bugs by severity, which are serious, grave, and critical bugs, which are the 3 severities of bugs that are considered release critical. And then we make a plot out of this, because we are keeping a history of these numbers. So we have an x-axis with the date, and y-axis with the number of bugs. We plot the serious, the grave, and the critical bugs. We add a legend, and we save the figure. And then with this, we compose a little text tweet, and we send it to Twitter through their API and using the Tweepy library in Python. And the result is something like this. It's a tweet that tells us the number of packages which have RC bugs and the time since the freeze began, or if it has begun or not. And then we can have some kind of idea of how far along the process is. This is not an objective measure, because we can't really predict the exact date. That's up to the release team, but we can have some kind of idea of how the process is going. I'd like to thank Molly White for the framework upon which I based this box, LaTeX and Beamer for this presentation, the Debian Release team, and the good folks in the IRC channels, especially Niels Fikier, who was of great help when I was researching all of this. Thank you very much. Contributions are very welcome.
My application is Repeater Start Ham Radio Tool for showing the Amateur Repeaters tool. So why ham radio? It works many places your cell phone doesn't. Cell phone internet or data or anything cell phone is not working out in the woods. It's not just some thousands of dollars large box anymore that you think of with ham radio. There's things like the Internet Radio Linking Project with a handheld radio, irlp.net. There's All-Star Repeater and repeater systems that are linked to all around your state or all around the world. And all this accessible with a handheld UHF VHF radio that's about $100 or less. So as many a ham radio user may know, it's often really quiet locally, just listening on the frequencies. So you use a repeater near you, often linked to lots of other places around the world. But where are the repeaters? Repeater Book is one not open source app. It is only for iOS and Android. There's another RFinder that's a paid app and also a proprietary app. This new one, Linux app, allows you to browse all the nearby repeaters and see all around the world, see all of those that are in the database. See what the IRLP repeaters are and see what the IRLP repeaters are linked to. You can click and then go to where in the world it's connected to. You can show everything offline. It stows all of the list of repeaters and the map if you cache it, so you can use it anywhere in the woods, for example. And it'll show a topo map, which the other repeater apps don't. This is open source GPL. It's a deb package for easy install on your Debian, Ubuntu, there's a Librem phone, pretty much anything. This uses the only open data repeater project I also worked on to have an offline list of repeaters that you can use in your application. See here, ham.live. So here's the interface. You can see the center cursor. Drag it to the center to select it. These are all the nearest ones, from nearest down to farthest. And there's controls. There's a control to go to your position. And there's a control to add repeater to a directory in the event you find a repeater that is not on the database yet. So what's next? You can find frequencies that nearby locals are chatting on, or you can use Repeater Start to get a listing of frequencies nearby you can listen to, either on the RTL SDR computer dongle or a radio. If you listen and you want to talk, you should get a ham radio license so that you can talk on the radio and use them where there are no cell phones. That's it. Thanks for watching.
Hi, my name is John Mercuris, and I'm going to be talking to you today about Nix browser. On my screen you can see two windows. On the left I've got Emacs, and on the right I've got Nix. And here I've got a little bit of a short summary about the things that we're going to go through, and then I'm going to demo them to you live in actually Nixt. So the first question you might have is, well, what is Nixt browser? And Nixt browser is a productivity-focused web browser that's written in Common Lisp. It's completely reimagined to make you as efficient as possible and not really getting in your way. So we take a bunch of concepts and ideas from editors that you might be familiar with, like VI and Emacs and other favorite CLI programs, and kind of integrate them into Nixt. The first one is the deletion of tabs. So Nixt doesn't have any tabs. They're actually buffers, and you can think of a buffer like a tab, but the only similarity that they share is that a buffer generally represents a singular web view, as does a tab. Other than that, they're quite different. So this allows you to switch between tabs or buffers very quickly. So I can actually open up a new tab here about elephants on Wikipedia, and I can switch very quickly between DebConf and elephants by, fuzzily typing in conf or DebConf, and I can open yet another one up about salmon. There you go. So now I've got a tab open about elephants and salmon. And this fuzzy matching extends to lots of other commands. So if we use our link hinting functionality, you can see that there's a link here titled African Forest Elephant. So I can actually just type in forest on the link hint, and it'll come up with the result for African Forest Elephant, and I can go ahead and go there with just a single click. The other really cool thing about our kind of mini buffer system that you see, mini buffer being this area here at the bottom, is that we can do multiple selections. So we can act on multiple objects at the same time. So I can go here to delete buffers. I can type in wiki, and then I can select all of the Wikipedia buffers at the same time, kill them, and I'm only left with a single buffer about DebConf. There's some other small features as well. There's so many to go through, but one of them that's pretty interesting is the jump to heading feature that kind of turns the whole document into a kind of a table of contents of what's going on. So you can look at core body temperature for elephants instantly if you wanted to. You can jump to there. But let's get to the technical stuff that makes Nixt really special, and that's that it has complete introspectability and modifiability. So I can go ahead and start Swank, which is, you can think of it like a LSP implementation for Lisp before this really kind of existed. So I start Swank, okay, and I can open up messages, and I can see that it probably has started. There we go. Indeed, it started. And so I can go in Emacs, and I can say connect with Slime. And just like that, I can see everything about the browser. So we've got a global variable here, browser, that represents an instance of the browser that we currently have up. And it's also going to show all of the terminal output here, messages, etc. So I can take this instance of the browser, and I can do typical Common Lisp operations like describe, and it's going to show me all of the slots. So slots, you can think of them like properties in another language. So it shows all of this information, and you might be thinking to yourself, that's fantastic if you're a programmer, but what if you're just in the browser and you want to modify something and you're not a programmer? Well, no problem. We've got a whole series of describe type functions. So we describe key, slot, class, whatever. So describe class, and we can say browser. And it's going to give us exactly this information, and actually a little bit more. It's a little bit more convenient here. We can see the type, documentation, the initial value, or the default value right here. This can do all sorts of things, but a cool thing is that you don't have to just search. You don't have to necessarily know the specific class for something that you want to change in the browser, because you can do describe slot, and it'll search for the slots in all the classes. So if I say URL, something related to the URL, what am I searching for? Oh, the default new buffer URL, which happens to be of the buffer class. Tell me about it. Here you go. So now you know exactly what its default value is, where it belongs, and actually how you can configure it. So we actually took it a step further, and we implemented a REPL directly into the browser itself, so you don't even have to have Emacs. So you can start up the Lisp REPL And here I can type things at the bottom of the screen. So I can do exactly what you just saw me do in Emacs. So I can say browser, okay. I can get a list of my buffers, which is pretty cool. And I can do anything I can in Common Lisp. So I can go ahead and print all the URLs, or rather return all the URLs of all the buffers that exist, which is pretty cool. Just like that. So I happen to have Elephant page open and DebConf page open. So what I really want to emphasize is that literally anything can be changed about Nixt. So in this execute command, this is my command here. I've removed the key bindings, but in the default implementation, the key bindings are there. How did I do that? Well, I just put this in my init file and it says, oh, okay, there's a new definition for this command, and so it'll call my new definition. So just to quickly go over these couple points here, every buffer is a unique instance. That means every buffer can have unique behavior. So the modes here are not global, okay? This is specific to this buffer. And if I go to a different buffer, like the help browser, you'll see that there's the help mode. Or if I go to the Elephant, help mode is gone. And the modes can specialize the behavior of the buffer. So it's like you can change the behavior by hooking into different things, changing the key bindings, and making things really context specific. So we've got very little use of globals throughout. Almost everything is hookable, dynamic. Literally everything is changeable. And the whole surface of our code is actually public API because it's designed for you to override things. And we take this actually really far, and everything, even the data that we store for your bookmarks or your history is in a human readable format. So if I go to Nixt, I can look at my bookmarks. Here it is, it's just an S expression. I can look at my history, look literally everything I visited, when I visited, all this stuff, and you can edit this by hand, process it, whatever you want it to do. It may look a little bit intimidating at first because it's Lisp, but believe me, you get used to it quite quickly, and it's no different than anything else. So I hope you liked this little peek into what Nixt is, and please give it a try. Thanks for your time.
Hello, I'm Mechtilde. I'm using Debian since 2002, and I'm maintaining some Debian packages. Since 2017, I'm a Debian developer. With my first package, I started to write a shell script to automate the process to prevent errors. I want to do all steps in the right order, to have the same quality for each version and each build. I want to manage all steps in one path and in one place. Around the different files I need for the Debian packages, I produced a detailed description. A description more than possible as commands. It gets more and more the more I learn about packaging. So a book is created. A book about Debian packaging. It is written in German. I did this using literate programming with NoWeb and LaTeX. This is a work in progress. Here you can find the work, the sources, the book as PDF and as a EPUB format. And here are the credits and license for the slides. I'm also online at OFTC.
Hello, I'm Elena or Valhalla, and I may have a small problem with Git. That is, if I can't put something in Git, it doesn't exist. A few years ago I had another problem. I couldn't find a microcontroller board that I knew I had somewhere. So I said, that's it, it's time to make an inventory of these things. And I looked at programs to manage this kind of inventories, and I said, that's it, it's time to write my own program to manage such inventories. I had looked at other programs such as Tellico, but I didn't like the way I couldn't really save their data in Git in a useful way. So I decided to use simple YAML files and Exapian index to be able to make searches on them. Each collection has a list of fields that I can fill. It's in the settings file. Various types and everything. And since this is a fresh Git clone of the repository, I need to create the Exapian index. And then I can search for something with Exapian full text free search or field searches on everything that Exapian allows. And in this case, this is my electronic components and devices repository or inventory. I've also been using it for other things. So, for example, I have an inventory of knitting needles, so I can do the same here. Index, and then, for example, search for a size 3 needle, and then I can look up at those files. Each file has an ID, and I know that all the details of that needle. So back to the electronics ones, I can also add new items. Something somewhere. And this opens my favorite editor, and when I save it and close it, it gets added to the Exapian index, and it gets added to Git but not committed, so that I can commit it after I've added what I wanted to add in one session. If you want to try it, it's still not in Debian, but it's available. I've started to do some of the packaging work, so if you're interested, you can tell me, and it's already on Salsa in the Python modules repository. So if you think this kind of things can be useful for you, let me know. I don't know if it's ready to be in Debian. I don't know if it's useful, so if you think it would be useful, I would be grateful if you told me so and said yes, I'm interested. Then I will be quite more incentivized to continue the packaging and everything. Thank you.
Hi people! Because lightning talks are so great fun, I will do another one. I didn't do slides because those just would distract you from my wonderful and very interesting talk. The topic of this talk is being bad. The truth about it is everyone is bad in almost everything. This is simple mathematics. There are infinite numbers of things you could be good or bad at, but there is just a finite number of things you can be good at. And in most cases this number is even very low. It's like, yeah, you learn things for years and you got good in them. Maybe 1 thing, 2, 3, 4, 5, even if it's 10 things, there is still an incredible number of things you're bad at. And this is true for absolutely everyone. And it is not a problem. What creates a problem is that one is supposed to only talk about things one is good at. If one is bad at something, one is supposed to not mention it, or at least to pretend that there are reasons you do it this way that are not you're bad in it. One example. At the beginning of my talk, I lied. The truth about why I did no slides is because I'm too bad doing slides. I never did good slides. They always have been crappy and useless, so I didn't do them. Another thing is I'm not able to memorize long things, so I only do lightning talks, because remembering everything about a long talk would be a problem. But I easily could say, yeah, I do this on purpose. I only do lightning talks because long talks are boring, lightning talks are interesting, and if people don't know anything about me, they would just say, oh, this person is great. He is doing great lightning talks. And this is possible with almost everything. You can almost twist things in a way that they sound very great. And then if you listen to people, they say, oh, it seems everyone but me is so good and I'm not. Yeah? But the truth is, yeah, if you are bad, yeah, don't worry. First of all, you can always learn, and the worse you are, the more you can learn. And the second thing is, being good is the exception. Being bad is the norm. Thank you.
Not just now. Hello. Thank you all for watching the recorded portion. Next up is Didier, because some people still do things on paper, and he's going to tell us about it. You're on mute.
I can start my intro again. Hello?
Yes, please.
Hello, everyone, and thank you for allowing me on the lightning talks at last minute. I just wanted to take a little time to talk about the Debian printing team. What have we been doing recently? Who's in the team and what comes next? So CUPS, if you have been following, CUPS is Apple's printing system that's been also shipped in Linux for quite some time. And here's a quick overview of the versions that we had. Jessie had 1.7, Stretch had 2.2. Buster also had a later version of 2.2, and Bullseye already has 2.3. There's a lot of changes. I'm not going to go through all of them. Let's go through the good. Actually, with CUPS 2.3 and in combination with CUPS filters, CUPS browse D, and everything that comes from the Open Printing project, we have a nice seamless driverless printing that's basically automated network discovery and queues creation. And we don't need any printer drivers for modern printers at all anymore. So that's the good part of the CUPS side. I've also already talked about that at various recent DebConf, but around 2016, CUPS moved from a behind closed doors SVN that was mirrored using a Git SVN thingy. Somewhere also had a private bug tracker and was just dumping toggles. But around 2016, it moved to GitHub and fully public, normal open source thingy. They also migrated the whole historical bugs database, keeping the bug numbers. They were actually working in public with clean separated commits and even accepting merge requests. So back to being a normal open source project. The bad, there's still a non-public bug tracker internal to Apple. So sometimes we see fixes with numbers pointing to something that's not public at all. So it's a huge problem. But the other thing is that the main forever CUPS developer, Michael Sweet, left Apple at the end of last year. And he went on to create another printing related project, but he was the main and if not only person working on CUPS at Apple, and he left. And now we come to the ugly. The last release we had on CUPS, the 2.33, was just one commit covering 2 CVEs, one unrelated warning fix, and the version change in one large dump commit. And this was pointed out in issues and in pull requests, and there was no interaction at all since from Apple on the public bug tracker. So we don't know if Apple is still working on Apple at all. Some behind the scenes contacts have been attempted, but no, not much success since. So the forecast is kind of cloudy on that front now. As for other printing related software, HPLib, the development team has changed within HP some years ago. They're still not using a public VCS. They have no visible concern for distribution patches. We basically never got anything merged, and we have something like 70 patches that we kind of share, at least between the Fedora people and us. We share these patches, so we were discussing the eventuality of forking this, but we don't really want to do that. And the most recent release, the 3.26, shipped with a huge regression that was only detected by distro packagers. So thank you to Zdenek Donal from Red Hat for having detected this. So it only got shipped in experimental in Debian because it would have broken the printing support for a large fleet of HP printers. So every time we get a new trouble from HPLib, it's always a fun game to discover what they will have broken, sadly. As for our recent changes in Debian, we have very recently added IPP USB for driverless over USB. It's a Golang package that will make a compatible USB printer look like an IPP network printer over the local network of your machine. That allows CUPS to interact with these printers using the same old IPP networking stack to talk to also USB connected printers. And there were lots of changes upstream side that were, of course, packaged for Debian on CUPS filters and CUPS browse D, which are the two programs that tie CUPS with the network and with your network printers. So nowadays, there are some things that should just work in Debian. Network printing to printers shared by CUPS. Tried that recently. You can print from Android a picture onto a CUPS shared printer over the network. It just works. Crazy, but it does. Zero configuration detection and setup of network, and USB printers. So printing just works out of the box. If you are connected on a Wi-Fi network, then you'll just get your printer appear either in the CUPS web interface or in the desktop interfaces, and you can just right away print to it, and it should just work. And a thing that is kind of unrelated to scanning, to printing that we did recently is also package and upload Sane AirScan that will use some of the public protocols for scanning over the network. So Sane AirScan will try to detect which of the scanning protocols are available and provide you the scanners over the network for any Sane compatible software to scan. So that should just work too. As for the meta changes in Debian, we dropped taskcell's print server in favor of CUPS because print server was a historical thing that provided various things that you needed to have a print server, but nowadays print server is basically CUPS plus everything that CUPS depends on. So we dropped this. It's probably missing still some release notes, but yeah. And Bullseye already has changes in to ship with a more minimal CUPS. So we dropped the dependencies from CUPS to the various drivers. There are some discussions, and I should also answer some of these discussions with regards to this. But the idea here is that CUPS plus the driverless plus CUPS BrowseD and everything that's now in Debian testing should basically give you a seamless experience with your local CUPS spooler and whatever printer, somewhat modern printers you want to plug in. The other drivers, we haven't removed them because they still work or used to work, but they will just not be installed by default. We might be revisiting this decision before the end of 2020, but that's the current plan. I think we have awesome documentation. I think it's very important to point that out. Check the Debian wiki /printing. For once, that makes the Arch wiki look pale in comparison. And it's the thankless work of one man, Brian Potkin. So thank you a lot, Brian, for massaging everything that is done upstream side on CUPS and CUPS filters and open printing into a Debian-specific, Debian-centric documentation that makes this very, very useful. So thanks a lot. So just a quick final note, I'm doing most of the Debian packaging for all the printing related stack. Brian Potkin, as mentioned, is our documentation master, but he's also our bug triage ninja. I often lag a little to answer the bugs, and often Brian has already offered an initial answer, pointed or updated the documentation. And yeah, that's really, really great to work with such a bug triage. Thank you, Brian, again. And Till Kempeter is working on the open printing upstream with CUP filters, Fumatic DB, etc., and is doing the Ubuntu side of things for what the packages are concerned. So thank you for listening. Continue to make Debian awesome. Continue to print using Debian. It should, and it is, just working. And continue to report bugs if there are, but not too many. Otherwise, I'll get bored. Continue to make DebConf awesome, and thank you all for the DebConf video and all the DebConf experience, the DebConf t-shirts, everything. It's really been great. Thanks a lot. That's all for me. Bye.
Hey. Okay, thank you very much, everybody, for listening. Eventually, I should appear on screen again, but otherwise I can just be the disembodied voice. So we're about to go to break now. After that, there will be 2 talks from the Malayalam track. If you don't speak Malayalam, there is the Puppet Sprint and also the Linux as used in the City Administration of Munich, in the Everywhere and the Ad Hoc places respectively. If neither of those are of interest to you, then you've got about 5 hours free now. So bye, enjoy.